Electricity is something we use every day, but in the few seconds it takes to flip a switch. Have you ever stopped to think about how far that electricity has traveled and the journey it takes to reach us? Power generated from sunlight in the vast deserts or from massive wind turbines standing in the open sea travels hundreds and even thousands of kilometers to light our cities and power our daily lives. And enabling this extraordinary flow of energy is an invisible pathway of connection. At the heart of it lies HVDC, the high voltage direct current cables. Hello, this is Jason Park, a sales and marketing manager of Hanwha Solutions, wire and cable division. Today, I would like to share how HVDC cable technology is reshaping the global power transmission landscape and the role Hanwha Solutions plays in this transformation. To understand HVDC, we need to look back quite far in history. In 1882, near Munich, Germany, a 2 kV DC system transmitted electricity over a distance of approximately 50 kilometers, the world's first long-distance direct current power transmission. However, as alternating current, or AC, became the standard for power systems, DC transmission faded into the backgrounds for many years. The reason was simple. AC made voltage transmission easier and power distribution more flexible. But by the mid-20th century, the need for efficient long-distance transmission, particularly for submarine cables and bulk power transfer, began to grow rapidly. As a result, HVDC technology regained attention. In 1954, Sweden's Gotland project became the world's first commercial HVDC transmission system. This was followed by major technological breakthroughs, thyristor-based systems in the 1970s, and voltage source converter, or VSC, technology in the 2000s. Today, HVDC is no longer just a transmission method. It has become the backbone of large-scale infrastructure connecting countries, regions, and even continents. So, how does HVDC differ from conventional AC transmission, or HVAC? First, power loss. Unlike AC, where current trends to concentrate near the surface of the conductor, DC uses an entire cross-section of the cable more evenly. This significantly reduces transmission losses, making HVDC far more efficient in transferring long-distance power. Second, simplicity of structure. HVAC systems require 3 conductors and wide safety clearances between them. HVDC systems, on the other hand, require only 2 conductors, positive and negative. This allows for smaller transmission structures and higher power capacity within the same space. Third, controllability. HVDC systems can precisely control the amount and direction of power flow using power semiconductor devices. This makes it possible to interconnect power grids, operating at different frequencies, acting as a bridge between otherwise incompatible systems. That is why today, Europe transmits offshore wind powers from the North Sea to inland grids, China delivers solar energy from remote deserts to major cities, and South Korea connects offshore wind farms to the mainland, all using HVDC cables. HVDC cables are far more than just thick power lines. They operate under extreme conditions, hundreds of kilovolts of voltage and thousands of amperes of current, where even the smallest defect cannot be controlled. To suppress space charge accumulation and maintain electrical insulation, HVDC cables demand exceptional material precision. That is why the most critical component of an HVDC cable is the insulation. Even slight material non-uniformity or microscopic contamination can concentrate electrical fields, leading to, boom, insulation breakdowns, and ultimately catastrophic system failure with enormous repair costs. To mitigate these risks, Hanwha Solutions has established a vertically integrated production system, manufacturing HVDC insulation materials from base resins to final compounds. From polymer materials such as LDP, EVA, and EVA to high-performance HVDC XLPE insulation and semiconductor compounds, we manage quality across the entire production chain. Moreover, Hanwha Solutions already supplies XLPE and Semicons globally for HVAC cable systems. In the HVDC segment, we are actively collaborating with leading cable manufacturers currently undergoing formal qualification and homologation processes for HVDC materials. This demonstrates that Hanwha Solutions' technological capabilities are being recognized not only in the AC market, but also in the extra high voltage DC domain. Today, the global power infrastructure is clearly transitioning from HVAC to HVDC. The scale-up of offshore wind farms, the increasing distance between renewable generation sites and load centers, and the growing numbers of cross-border grid connections all demand HVDC solutions. According to CRU Group, a global market analysis and consulting firm, HVDC cable demand in Europe is expected to surge from 2025 onward, with approximately 32,000 kilometers of new HVDC cables projected to be installed by 2031. In Europe, China, and the Middle East, HVDC projects have already become the standard for the grid expansion. However, while demand continues to grow rapidly, the number of suppliers capable of producing HVDC cable materials remains extremely limited. Strict homologation processes, high technological barriers, and uncompromising quality standards have made the supply chain increasingly tight. Against that backdrop, the role of Hanwha Solutions is becoming more critical than ever. With advanced HVDC installation technologies, integrated raw material production, and the global homologation capabilities, Hanwha Solutions is well positioned to become a key global supplier of HVDC materials. This is not simply a business opportunity. It is meaning contribution to global electrification and the transition toward a sustainable energy future. We're living in an era of energy transformation. Power must travel farther, in greater volumes, and with greater stability than ever before. HVDC cables lie at the center of this transformation, and at the center of the materials that make HVDC possible is Hanwha Solutions. Through continuous innovation in our wiring cable business, we will continue to connect the world's energy networks that help build a more sustainable global power infrastructure.